The overall goal of the following experiment is to construct an electronic tongue based on a combinatorial approach and perform surface plasmon resonance imaging for protein analysis. This is achieved by using lactose and sulfated lactose as building blocks and depositing their mixtures on the gold surface of a prism for self-assembly to create an array of combinatorial cross-reactive receptors. As a second step, surface plasmon resonance imaging is applied, which monitors binding events in real time and produces SPR images and a series of kinetic binding curves called sensorgrams. Next, data processing is carried out based on the sensorgrams using a math computing software in order to create a 2D continuous evolution profile and a 3D continuous evolution landscape for each sample. The results show the electronic tongue is able to generate distinct 3D continuous evolution landscapes for common purified proteins and is efficient for their discrimination based on pattern recognition.
This technique has several advantages over existing methods like classical electronic gnosis and tongues. First, the preparation of sensing receptors is largely simplified. A great diversity of cross-reactive receptors can be obtained by mixing a small number of molecules. Second, thanks to the combinatorial approach, the recognition patterns generated by our electronic tongue can be considered as continuous, so that abnormal signals can be more easily identified. Therefore, more reliable analysis can be obtained.